What is NAD? What does it do in our body? Do we need it?
We wouldn't survive for a minute without it. So it's an absolutely essential molecule in the body. I published over 150 papers on this.
I see a lot of people still having monthly NAD IV.
What's missing, though, is common sense because it can't go in and the stuff that's in can't go out. And there is no transporter or shuttle or hole or anything on the outside of the cell to suck in that NAD and bring it into you. It doesn't exist. Many people, even doctors, don't realize this, that by giving supplements with NAD, you're actually providing that fuel that the cancer cells need. I'm actually going to spend the next 10 years of my life, and this is the truth, focused just on creatine research. Your brain runs completely dependent on creatine.
I'm Dr. Esra Çavuşoğlu, and I've been living a sober life for the past 20 years. My battle with addiction drove me to seek new methods, devices, and supplements to improve my physical and mental performance, enhance my quality of life, and ultimately live healthier for longer. From my experiences in addiction recovery, biohacking and longevity, to the latest global developments, from groundbreaking entrepreneurs to expert academics, the conversations I've had over the years are now featured weekly on Soberhead Podcast.
Welcome to Soberhead Podcast. Today I'm joined by Dr. Andrew Salzman, a Harvard and Yale-trained physician scientist and one of the leading voices in NAD biology, NMN, mitochondrial health, and the science of cellular aging. NAD has become one of the most talked about molecules in longevity medicine. We see it everywhere now. NAD IVs, NMN supplements, NR, anti-aging clinics, biohackers, celebrities, and every few months a new study comes out. Sometimes very promising, sometimes much more cautious. So today, I want to ask the real question. Is NAD one of the most important molecules for health span, or has it become the new longevity hype? We talk about what NAD actually does inside the cell, why it declines with age, whether NMN can truly restore it, how this connects to energy, metabolism, inflammation, insulin resistance, DNA repair, and brain health. Most importantly, what we know, what we don't know, and what the public should be careful not to misunderstand. Let's dive in.
Üniversiteyi sadece dersler, vizeler, finaller olarak düşünme. Asıl mesele okurken kendini keşfetmek, üretmek, projelerde yer almak ve mezun olmadan gerçek dünyayı tanımaya başlamak. Bir yandan psikolojiyle insanı daha iyi anlayabildiğin, beslenme ve sağlık bilimleriyle iyi yaşamanın ne demek olduğunu öğrendiğin, mühendislik ve yönetim bilişim sistemleriyle teknolojiyi, veriyi ve sistemi çözümleyebildiğin bir üniversite düşün. Yani sadece bilgi aldığın değil, düşündüğün, ürettiğin ve fikirlerini hayata geçirebildiğin bir yer. İstanbul Gedik Üniversitesi, öğrencilik hayatını gerçekten yaşarken geleceğini kurabileceğin bir deneyim sunuyor. Ayık Kafa'nın daimi destekçisi Gedik Eğitim Vakfı'nın sağladığı katkı ile size dünyanın önde gelen uzmanlarını konuk olarak getirmeye devam ediyoruz. Siz de Ayık Kafa'ya abone olarak destek verebilirsiniz.
Dr. Andrew Salzman, welcome to Soberhead Podcast. It's an exciting time. The topic is very exciting. I receive a lot of questions about NAD, nicotinamide adenine dinucleotide. All right, I was able to say it. I know that you've been doing your researches for a while now around NAD and the precursors. In my opinion, there are a lot of misinformation out in the public. And actually, recently, there was one study came out and they were measuring NAD levels in the blood biomarker. And once they found that, there's nothing is changing, etc., the whole field, again, these longevity doctors starts texting each other, Instagram post, people are texting me, were we taking for no reason, and etc., etc. So welcome to the podcast.
Thank you.
I'm very honored. You're a highly respected physician and researcher in the United States, around the world. For the last, let's say, 6-7 years, you're focusing a lot to NAD. You had other things. Can you tell a little bit about you? Because, maybe
Sure.
my audience would like to know about you, your career.
Okay, well, thank you very much for the opportunity to be here. It's a real treat for me. So I'm from the U.S., as you said, and I grew up in Boston, and then I went to college at Yale University. And I became fascinated by biochemistry there And I went on to medical school at Harvard Medical School in Boston. And at the conclusion of that, I decided I wanted to be a pediatrician. Love working with kids. And so I went to Columbia University and I did a residency in pediatrics. And at the end of that, I decided I wanted to go into infectious disease and as well as. So I went to Israel. I was newly married, and I worked at the Weizmann Institute doing basic research on immunology. And I was invited back to Harvard after that to study infectious disease and intensive care. So I spent 10 years there. And during that time, I did clinical training and research training in infectious disease and neonatal intensive care, pediatric intensive care. And I developed the gut leak concepts there with my boss, Mitchell Fink, really the pioneering work in the late 80s, early 90s. And then I was invited to go to Cincinnati, to the largest children's hospital in the country, and I became the director of intensive care there. And I did that for 5 years, and I built a big research program there on NAD, actually. We can talk about that.
It goes all the way back there.
Oh, well, my work on NAD really began in 1988.
Wow. Nobody was talking about it.
Not too many, but I was fascinated by it, and I still am. And then after that, after 5 or 6 years, I decided I could be helping more, could contribute more by creating a pharmaceutical company, which would have the resources to develop new drugs for people in this area of NAD. So I left and went back to Boston, and I built a company, and we invented the first PARP inhibitor. And then I licensed that to Genentech. And then I went on to develop and discover new treatments for glaucoma based on new pathways I had discovered. At that point, I then went back to Israel with my kids and my wife. And I opened up a consulting practice, and I ended up running a company, and we invented a new drug for metabolic diseases in children. We had a big exit there with that. I've spent the last 15 years doing basic research, and then I had the incredible good luck to run into Baran Delaver and with his company, Wonderfeel. And so I've been with them now 7 years.
Okay, wonderful. What is NAD? What does it do in our body? Because I want to be very educative to my audience. There's a lot of, in one hand, misconception, on the other hand, too much sales happening, not necessary interventions. And I think at this point, everybody is very confused. Some are bashing NMN, NAD, NR, whatever. Some are super fanatic. What is NAD? What does it do in our body? Do we need it?
NAD is one of the key molecules in the body in terms of metabolism, DNA repair, physiology. It's a core molecule. It's a very central molecule. We wouldn't survive for a minute without it. So it's an absolutely essential molecule in the body. And it's involved in just about every process you can think of. It is the key molecule in the production of energy in terms of mitochondrial production and outside the mitochondria. It is absolutely essential for DNA repair. And that was my area of research in my first company in terms of its relationship with PARP. It is very involved in the regulation of functions in the cell, like with sirtuins. It's very important for the production of nitric oxide, which is essential for so many different processes. It's essential for antioxidant function because of its conversion to NADPH. So it really has a hand in everything. And so whether
like reproduction and everything?
Yes, sexual health, reproductive health, mental health,
mental
digestion.
Health?
Oh, sure. And in disease, it's very important. I mean, how it's managed in certain diseases. We were the first to show back in 1994 that NAD levels, for example, collapse after heart attack and stroke. And that if we augmented those, if we dealt with that problem, if we resuscitated NAD, we could prevent damage to the heart and to the brain and stroke. We showed that it was critical for diabetes. We showed it was important for cardiac health, cardiomyopathy, traumatic brain injury. I published over 150 papers on this, and it just is incredibly important in so many different diseases. And then recently I became part of Wonderfeel, and we focused on a different subject, which was longevity. This was not something I had worked on before, but the preparation, the understanding of the biochemistry of it gave me a good place to begin. And so I spent the last 5 years focusing on the basic science of NAD in longevity and staying well. And that's proven equally interesting. So I think it's a fantastic opportunity to talk about this today. Very important molecule. Now, the supplement is different than that. The supplements are now asking the question, okay, do I need to take more? Is it enough just to take it from my diet, or do I actually need to take a supplement? That's the question there.
Let me jump in for a very quick second. If you can hear me right now, we know you're watching Soberhead. But are you subscribed? Could you check it for me? Very honestly, our subscriber count gives us real leverage when it comes to convincing the guests we invite to join the show. So, if you want to keep watching some of the best experts in their field right here, please subscribe to the channel.
Let's continue with, I guess the important part is that how do we get deficient in NAD?
Right. Well,
what happens?
Yeah. So NAD is actually not something you can eat. NAD is made in your own body by your cells.
How?
Well, the cells have two pathways by which they can make NAD, and they use earlier molecules, let's call them precursors, which you can eat, which you do eat. And these are things like nicotinic acid, nicotinamide. So these are vitamins, if you will. So you take those, they get into your intestine, you absorb them, they go into your blood, and they circulate around your body until they go into the cells. Once they're in the cells recognize them and convert them inside the cell to NAD. So
But
that's
how about when we're like 5 years old, 10 years old?
It happens all your life. The problem with the NAD deficiency, which is what I think we're talking about.
I'm trying to understand, like, up until what age it starts declining.
Yes. So the levels of NAD inside your cell are governed by two opposing forces. On the one hand, you're making it every day, every second. Your body is making NAD. That's a good thing. But at the same moment, there are also mechanisms inside and outside the cell where the NAD is broken down, where it's consumed, it's used up, it's depleted. So the actual level that you have in your cell is a balance between what you make and what you lose. And that balance, which is somewhat precarious, can go up or down depending on the situation, that is the level that you have. And the concern over time with aging is that balance starts to slip away. It starts to go down.
Why?
There is a slight reduction in the production as you get older. It's not that important, but it's there. There's some slight diminution in how much you make. But that's not the whole story. More importantly, you use it up. And there are mechanisms, particularly with enzymes that can chew it up or cut it up, that deplete it over time. And those enzymes increase as you get older.
Like?
Well, the most important one that's been mentioned is CD38. So this is an enzyme that's in many cells throughout your body, and you have relatively low levels of it when you're a youth, when you're young. It's there, you need it. It produces some things that are useful for fighting infection. So from an immunologic standpoint, it's good to have a little bit. But unfortunately for us, this enzyme increases as we get older.
With inflammation.
With inflammation, the regulation of this enzyme is such that inflammation increases its expression, its production. So as you get older, there's more and more and more. And by the time you're 60, 70, 80 or whatever, you have a lot of it. So then the balance changes. You're making a little bit less of NAD. Okay, not that much, a little bit. But now you're using it up. You're depleting it. So you end up, it's like a bathtub with water going in and a drain with water going out. The level of water in the bathtub is governed by how much water goes in, how fast it goes in, and how big the drain is. So the CD38 is the drain. It's draining it. It's removing it.
Typical mechanism when we get old, the inflammation, if you eat bad, you get old, whatever. So CD38 increase chews up the NAD. Why?
That's what it does for a living. The CD38 enzyme recognizes and binds to NAD, and it has like a scissors, an enzymatic scissors, and it cuts it in half. And why does it do that? I mean, there's a reason it's doing that. The CD38 enzyme uses NAD to make a new molecule that's important for immune regulation. So it uses that as a substrate. It uses that as a foodstuff, if you will, to make this new molecule. So it has its reasons for doing it. The problem is that it gets out of control. There's just too much CD38 as you grow.
What happens when there's too much CD38?
Well, I'll give you an example, a real-life experiment, okay? So we know that CD38, it's present in many cells, but particularly in the ovary, okay? So in the ovary, in a young person, a young woman, every month there are new follicles that are produced, and then you have ovulation and the egg comes out and it can be fertilized. So in order to do that, you need energy to have the follicle grow, to have the egg nourished, and then to let it hatch, if you will, to come out. The cells that surround that in the ovary and the follicle become very rich in CD38. And so they start lowering the NAD all around the egg to the point where at menopause you have so much CD38 and so little NAD that the ovary just basically stops working. Now they took mice.
So hold on. Okay, now I have to get a bit more in that.
Yes.
So do you think ovaries stop working because of that imbalance?
I do, and I'll tell you the data on that.
Oh, wow.
Okay, so there was a beautiful study published in mice in which they created a special strain of mice that have zero CD38. None at all. Zero. And these mice, of course, mice don't live that long. They live about 2 years. But the age of a mouse corresponds to like 45 years for a human. So a 2-year-old mouse is about like a 90-year-old person. So they looked at the ovaries of these mice, and they could see CD38 going up just like it would in a person. And they saw the NAD levels go down, as you would see in a person. And when they took these special mice that didn't have any CD38, the NAD levels were much better because there was no CD38 around to cut it in half. What was even more interesting is that the mice behaved functionally like young mice. So they had, mice stop having litters when they're about the equivalent human age of about 50. These mice that were 90 were having babies right and left.
Wow.
And they were ovulating, and they were absolutely their normal estrogen levels, and on and on and on. So the absence of CD38 in these animals confirmed its relevance to the biology of NAD and to its function. So it's clearly very important that we watch CD38, that we understand it, and ultimately, I think as physicians and as healthcare providers, we need to start thinking about lowering it. It's sort of like cholesterol. It's something that's out there that's probably not great to have. And there's a medicine for that, the statins, and millions of people take it. CD38, there isn't a medicine today. There's no pharmaceutical. But I predict that in 10 years, we will be taking CD38 inhibitors just like we take statins.
I want to stay a little bit on the reproductive organ because I know like Melinda Gates just donated, I think, $250 million for reproductive health and how to figure out to maybe extend the life. I know a friend in New York, which I interviewed, Piraye Yurttaşbayım. She's a researcher and she had a company called Cellmatics, and their goal also was to be able to extend that. So if there's such an mechanism, can you just let's say, because you said CD38 at some level we need it to fight
at a low level.
Low level.
Yeah.
If there's a way that they could figure out to just focus to the ovaries for the CD38 blockage.
It wouldn't be possible to do that on an organ level like just the ovaries. But generally, I will tell you that CD38 excess and NAD deficiency are generally not good things. I mean, when we look at all of what NAD does, this is not something you want to have deficient as you get older. And many of the aging problems that we have, whether it's in digestion or mental processes or cardiovascular health, sexual health, muscular health, they all tend to become worse over time as one ages. It's part of the process of aging. So I would say if one could develop a CD38 inhibitor, and there's pharmaceutical work on that. Oh, yeah. I think this will become a staple of modern medicine.
At the beginning, not like a few minutes ago at least, you mentioned that, the bucket or a tub, overflow tub, like it becomes like CD38 is fed by NAD. So I think the people that I was just sharing at the beginning, there's one school of thought that just started saying like, we don't want you to take NAD, NMN, whatever, NR, because we don't want to feed CD38. And one school of thought, like yours, this is quite impossible because if you don't have NAD, you'll be dead soon.
You'll be unwell.
You'll be very
Yeah,
sick,
yeah.
or you cannot function well enough, etc. There's a bucket. The bucket has a hole, and no matter how young you are, how old you are, if you're able to produce NAD, workout, food, sleep, whatever, and at some point you can keep filling out that bucket, you will have energy. But because of that hole, you're getting older, you keep losing it. And
That's
that
correct.
feeds CD38.
I wouldn't call it feeding it. The CD38 is cutting it in order to make a molecule from
So
it.
CD38 do that bucket hole.
There are two
the
enzymes
hole.
that are making that whole. One is the CD38, and the other one is PARP.
Okay.
PARP is very important. We need it for DNA repair. It prevents us from getting cancer. It's critical enzyme. And PARP uses NAD when it's working. A small amount. CD38 is much more aggressive. So taken together, both of these enzymes, they can chew up quite a bit of NAD.
I kind of did a little research before you came. So basically what they say, the scientists or doctors who are concerned about the CD38 part of it, it becomes like more you fill the bucket, more the hole is bigger and CD38 gets fed.
No, the CD38 is there because it's expressed in response to inflammation. The amount of CD38 doesn't go up or down because of the amount of NAD. It's just there.
Okay, now let's continue with NAD, NMN, NNR supplements. I would like to first start with NAD IVs because it first started kind of like that until the NMN came up by, I think it was David Sinclair who came up with
That's
NMN,
right. Yeah.
the precursor. NAD, I did it as well, IV NADs, and they said like, oh, it helps in the addiction, it helps in when you're very exhausted, etc. It is really a long process to have that IV. It's expensive. And then they say like, well, it's not working. It is really not working because I still know many doctors in the United States, in Turkey, in Greece. I just spoke with a friend. I told you before having the podcast. She's a MIT graduate friend of mine, not like some like pushed around person that wanted to have an NAD IV. She goes like, oh, I'm going to go to see my doctor, my monthly NAD IV. I see a lot of people still having them. Explain to us, please, if it's working, how it's working, and if it's not working, how it's not working.
So let me begin kind of in relationship to that to say that NAD is made inside cells. It's not made outside cells. It's something that happens inside the cell.
Why?
Because the cell has the machinery there to produce that. There are three mechanisms inside the cell that are generating NAD. Those are inside every cell.
Are there names for these mechanisms?
Yes. I mean, there's the price handler pathway, which takes nicotinic acid, and it's able to generate NAD. And then there's the salvage pathway, NMPT pathway, that takes the remnants or the products after NAD has been used and can recycle it. It's a recycling. And then, of course, there's the natural ingestion of various precursors which come into these pathways. So there's a whole process, but all of this happens inside the cell. I can't emphasize that enough. It doesn't happen outside cells.
You said that in another podcast. It's so valuable. You said that the cell has a protection that it doesn't get out of the cell.
Yeah, it's
let alone getting in.
Look, if you are investing in anything in your life,
you want to hold it.
Yes, that's why people put money in the bank.
Sure.
They don't leave it out on the sidewalk. When you invest something in your life that's important, you want to preserve and protect it. This is a natural thing that humans do.
So is it very difficult for the cell to produce that?
Yes, it's a lot of work. It takes energy to make it. It's a concerted process. It's a whole process in there. So it's not going to make a molecule, in theory, that it would lose, that it would dispense with. It will preserve and hold on to it. It needs it. It's precious for the cell. The cell depends on it. Now, it so happens that all of the energy molecules the cell makes, not just NAD, but also ATP, for example, ADP, all of these molecules, it's a lot of work to make them. Think about where they came from. We don't have energy for free. Unlike plants, we don't photosynthesize. We don't use the sun. If we need energy, we have to go into the world and either eat, well, we have to eat something. Hunt or forage or look for blueberries or whatever it is. But humans and all animals all animals, have to get their energy from the environment. So they eat. Once you bring in this food, you have to convert it to useful molecules in your body. It's a lot of work to go hunting and foraging and so forth. So the energetic molecules that we make, we hold on to them like crazy. We use them sparingly. We use them intelligently. The body has very special ways to protect and harvest these so that we don't just go out and waste it. If we wasted our energetic molecules, what would be the consequence? We'd have to go out and hunt more, which exposes you to predators and exposes you to risk and damage and trauma. So the body holds on to energy like crazy. And therefore, the NAD, when it's made, is kept inside the cell, just like ATP. How does the cell do that? Because NAD and ATP are charged. They have an electrical charge on them. It's a negative charge. The cell membrane is made of lipids, of fats, and you can't put an electrically charged molecule through a wall of fat. It won't work. It bounces off. It will not go through. So once it's made, it stays in there. The corollary of that is that if there's something charged on the outside, it can't get in. So when you took your NAD infusion, in your blood was a very negatively charged molecule. And there is no transporter or shuttle or hole or anything on the outside of the cell to suck in that NAD and bring it into you. It doesn't exist.
Did you guys look into it?
This has been published for years. It's been known for 40 years.
Why do they still?
I can't speak for the people who do that. I imagine that their intent is good, that they're trying to increase the levels inside the cell by giving the molecule that's needed. What's missing, though, is common sense, because it can't go in and the stuff that's in can't go out. So this is no way to increase the NAD inside your cell. If you want to increase the NAD inside your cell, you have to be more clever. And this is where in the last 10 years, the supplement industry took notice. So for example, there are precursors along the pathway of NAD production in the cell.
In the cell.
The cell has a process.
I just want to ask, before we come into this, with age, if the person is very, very healthy, do we lose NAD production just with age? Like, like eggs, women lose at the birth. Young girls or baby girls start losing their eggs, like from starting by 0 until...
I see your question. You're wondering if we start off with a certain amount that we lose. No, NAD is produced every second of the day.
Okay.
In one day, you're producing an enormous amount.
I would like to help people, young people also watch us. Like, which activities are, besides supplements?
Well, the problem, as I mentioned, is mainly with CD38. CD38 is chewing up and destroying NAD. So then the question should be, why do we have so much CD38?
So you don't need to do like extreme workouts or whatever. So you automatically...
Well, no, let me come to this. The CD38 increases over the years for a reason. And the reason is that inflammation stimulates its production. So if you are having inflammation, even at a young age, you will have a lot of CD38 and you will lose NAD. It just happens that as people age, 40, 50, 60, 70, so forth, their body has more and more and more CD38 expressed because we have chronic inflammation that's growing.
Let me jump in for a very quick second. If you can hear me right now, we know you're watching Soberhead. But are you subscribed? Could you check it for me? Very honestly, our subscriber count gives us real leverage when it comes to convincing the guests we invite to join the show. So, if you want to keep watching some of the best experts in their field right here, please subscribe to the channel.
I took a note over here. Say you call NAD central to metabolism. And for a regular person listening, that low NAD should feel like fatigue, slower recovery, metabolically not that healthy, and brain fog and stuff?
NAD is involved in all of that. It's a central molecule that is used every second for making ATP, for making energy. If we don't have NAD in our cell, we can't make any energy, any ATP, zero. In fact, we published back in the 90s that this is an extreme example, but it illustrates my point. If you take a person who has a heart attack, so they've lost coronary blood flow to one of the blood vessels in their heart, So we did this in animals. And what we saw is that when you ligated, when you closed off the blood vessel in the heart, after you lost your NAD within about 2 to 3 minutes, maybe 4 minutes. And then by minute 5, there was no ATP. And so you get an infarct. That's what a heart attack is, or a stroke. So NAD has been known, even since the 1940s, NAD has been known to be absolutely indispensable for ATP production. We know exactly where and how and what it's doing. We know how NAD is used to make ATP. It's involved in the 3 different mechanisms for ATP production. There's glycolysis, the Krebs cycle, electron transport, and the mitochondria. All of that requires NAD. No NAD, no ATP. So this is accepted. Every scientist and physician in the world would agree with that. The issue now is, what do you do if your NAD levels start to fall as you get older, as CD38 rises? And that's really the crux of the matter. What is the best way to address that?
Yeah, let's come to that, because there are 2 precursors, actually 3, niacin also, NMN, NR, and niacin. What are these?
Well, inside the cell, as I mentioned, NAD is made. It's not made in one step. Actually, there are about 4 steps. It's a pathway. You start with the raw material, you process that to the next step, you process that to the next step, and then you process it to NAD. So there's 4 different steps along the way. There are 2 different pathways, but each pathway is 4 different steps. Now, the stuff on the way are called precursors. So we know about those. So someone about 10 years ago said, hey, we can't give NAD because it doesn't go into the cell. Why don't we give the cell a precursor? Give it a boost, give it a help, give it something along that pathway of 4 steps. Some people thought, well, let's give the first step. Why not? It's a vitamin B3. Let's do that. And so some people take nicotinamide or methylnicotinamide, niacin. This is the very first step. So you'll see people do that. But the problem with that is that one of the precursors, one of the vitamins, which is called nicotinic acid, wonderful precursor, by the way. It's great, but there's a terrible side effect. It causes flushing. So it's not used clinically. So then people said, well, that's a problem. We can't use the first step. What about the second step? That's a good idea. And that's called NR. So suddenly you see all these products on the market for NR by Niacin and other companies. And then when someone said, well, why the second step? Why not the third step? That's NMN. And then you saw companies develop NMN. These are all precursors. They're along the pathway to get to NAD. And then the question became, okay, you want to take NR? You want to take NMN? You want to take niacin? What are the pros and cons of that?
Yeah.
Is it tasty? Does it cause side effects? Is it hard to absorb? How long does it stay in the blood? Does it get into the cells? I mean, all of these good questions came up, so that we now had several therapies, if you will, with different precursors, and people could compare them. And that built that supplement industry, having those available.
Then, it takes much longer. I think somebody gave me this analogy. Like, one is like eating oranges or directly drinking orange juice, or having a vitamin C supplement. So there are steps, and, the body to convert takes much longer if you eat oranges. If you drink orange juice, a little faster. But if you take vitamin C supplements, it's directly you get it.
I see where you're going with that.
Steps.
Some people thought that if you take something almost at the end, that the IV infusion industry, that's where they got this idea. Well, we'll give NAD. It's already made. Problem there, it doesn't get into the cells. But then people said, well, NMN must be better than NR because it's closer to the finish line. And that was the impetus for believing that NMN, one of the reasons why NMN was thought to be superior to NR.
I was searching, as you know, before you were coming in the last few days. There are some studies shows that NMN can improve NAD level, but also with it insulin sensitivity or muscle function. So these are really great things, but these are short terms and small amounts. So it's not just energy, it seems like. And you said mental health. I'm very interested into that.
Well, when you talk about muscle function and insulin sensitivity, all of this ultimately feeds back, in many cases, to energy. For example, in order to have muscle function, you have to make muscle. You have to maintain the muscle. You have to regulate it. You have to make sure it's repaired. People tend to think about the body as sort of, I have a body. I'm a human. I have a body. And if I don't do anything bad, I mean, my body will be kind of there. But what they don't realize, I don't think many people, even doctors, don't realize this by and large. The body is actually a totally constant process of repair and regeneration. You don't just have a body. Your body is being repaired. If people knew about this, I think they'd be frightened in a way. But I mean, the body is totally replacing itself every few days. The intestine, for example, is completely replaced every 3 days. Muscle is replaced. Bone, even when you start walking, if you start walking, carrying heavy things, your bones will get bigger. If you sit in a couch potato, your bones will get smaller. Every single thing in your body is constantly being regenerated, repaired, and fixed. So this process is going on all the time. If you don't have NAD there to fuel this process, eventually you will accumulate wear and tear, or you just won't repair as fast as you should. Once the damage exceeds the repair, you start to age. What is aging? Aging is the crossover between the accumulation of damage and the ability to repair. There's a balance. When you're young, you're 5 years old, you have phenomenal ability to repair.
You heal much faster.
Yes, I'm a pediatrician. We had kids in the ICU who were very ill. And a week later, they might come in eating an ice cream cone. These kids were amazing ability to bounce back. You hit them to the ground, they jump up. Watch a 2-year-old sometime. They fall down, they get right back up. Watch a 90-year-old person fall down.
You fall down and you're done.
Yes. So the balance between damage and repair is there all the time. And unfortunately, as we get older, the damage still happens. Maybe even doesn't change much, but the repair is going down and down and down. And so in order to fight that inflection, that change, it's very important to maintain as good health as you can so that your repair processes keep up with the damage.
I would like to ask about that study that came out 2 weeks ago, I guess, or 10 days ago, that, wow, there was that, NAD levels doesn't change in our bloodstream. And then everybody started, everybody was almost waiting at their corner to attack NAD or NMN or whatever. So what is that about, and how valid is that study?
This is a great question that you're raising here. So I was frankly shocked by that publication. It's not that they did a bad job. I mean, the publication was very well conducted. From a scientific standpoint, they did all the right things and they measured everything properly. But the question was wrong. If you look at the question that they really wanted to answer was, is NAD stable or is it falling with age? This was their interest. But what they did, instead of measuring NAD in the cells, which is where it's made and where it counts, they measured it someplace else. They measured it in the blood. NAD has nothing to do with the blood. Like I said before, the NAD is made inside the cells.
Was there even NAD in the blood?
There was. It spilled out. I mean, when cells die, they release NAD.
It should have something.
Yes. I mean, when cells are dying, they break open and things spill out of them. So you have some NAD in the blood, but it's irrelevant. The appropriate thing to have done would be to directly measure in tissue the amount of NAD. That could have been done, but they didn't choose to do that. And they left the erroneous impression that NAD levels are stable, but they were looking at something which was a pool of NAD, as I said, from broken dead cells. That has nothing to do with the NAD that we care about, which is in living cells. So I didn't understand why they published that. They left the false impression. A lot of people got quite frightened about the results. They didn't explain in the paper the relevance or irrelevance of blood levels. They made it sound as if, this is the story. It's not the story. So that was a mistaken impression, and I was quite shocked about the whole thing.
We built a treatment center for youth in southeast of Turkey. And there was this master's level student interning with us. And he wanted to conduct a study with the boys that were residing with us. It's a 6 months residential. I don't remember the details, but I said, this is such a stupid study. Like, you are in a treatment center and you're trying to measure something that has no relevance if when these kids or young youth leave the center, has nothing. They're in a closed place. Obviously, your study's outcome is going to be nothing relevant to real life. So I see that sometimes, I mean, I'm no researcher, don't misunderstand me, you did a lot of research. I think getting that much publication was wrong rather than maybe these guys were trying to see if what's happening in the blood.
Well, I don't know what they were trying. I don't know their real intent or their motives. I assume they're good people. But the problem is the question they addressed was framed in such a way that a normal person reading that would be led to have a false conclusion.
Yeah.
And that, I think, is a serious problem. They've disparaged the field, basically, giving the impression that NAD is stable when, in fact, numerous studies, both in animals and in humans, have shown that it falls. In the animal studies, I've just given you an example of one, but there are many. And there are many studies in humans. So I didn't understand why this was published, and I think it's given considerable damage to the field.
There are some supplements out there. I want to touch base for a second to CD38, like Apigenin, maybe Quercetin, that can block a little bit this spillover or the CD38.
That's correct. That's absolutely correct. There's some natural food supplements which have a slight inhibitory effect on the activity of CD38 and therefore can help preserve NAD levels because they interfere with it, breaking it down.
Okay.
That's why in the product that we developed at Wonderfeel, we included various things which have been shown to inhibit CD38, albeit mildly. They're not potent inhibitors. We didn't want potent inhibitors because, as I mentioned at the beginning, having a little bit of CD38 is actually a good thing. You need a small amount. You don't want to wipe it out.
So can you just take the inhibitor and not take an NAD, NMN?
In theory, that would be probably okay. But as I said, there is a slight fall off in the actual production. It's not a lot, but there's a slight fall off in the production of NAD. So I think even if you took a potent inhibitor of CD38, I imagine you might need to take a supplement. I'm not sure. We'd have to see clinically. As of now, no one has developed a super potent CD38 inhibitor.
I listened to you. In Turkey, it's so funny. They allow only 50 milligram of NMN.
Yeah.
50.
Yeah. Very low amount.
I have scientist friends. They say like that does nothing, like nothing.
Yeah.
Europe is 300.
Yeah.
America is like everything. There's no limit, I guess. Maybe 1,000.
Well, there have been studies that have been done up to 2.5 grams per day.
Few questions I want to ask together. Because we cannot measure, you said that. In studies that, in laboratories, you can probably measure in cell cultures, but not in real people, like what's your NAD
You would
level.
need to take a biopsy from a person.
Yeah, and that would be difficult, I guess.
Yes.
So you cannot measure. Is there too much of it? Is there you're taking too much? What would be the after what age? Like, let's say, is it like when you're 30 years old and healthy? Because, in supplement industry also, there's this thing. I'm one of them, by the way. Don't misunderstand me. I get excited about a molecule. I want to take it. I want to take the maximum dose without knowing if it's going to help me or not. So are there some guidelines? Hey, if you're healthy and 30 years old, 250 milligram would be okay. When you're 50, whatever. Is there such thing? Or it's just
there should be, really.
Random.
It is random. There should be that. But since there hasn't been a way easily to measure the NAD levels in cells in people, it hasn't been done. I mean, it's been done in some research, but not in the general community. So as a consequence, we really don't have a way to know definitively if someone's receiving enough or too much. So we've used in our own work, we've used an average. We know that in studies by Sinclair, when he gave 2.5 grams per day, that people tolerated it. So we knew there was a safety margin. We could see that. So in giving 900 milligrams per day, which is our recommendation, we were well below the maximum that had been evaluated and that was safe. So we felt comfortable about it. But you're right, there needs to be a more definitive way to do this, and it would be great if we had a clinical way to measure intracellular NAD, and we do not.
But I guess you guys are doing some studies in India. Maybe you can try in the urolithin A studies that they did. Older people with younger people with whatever, and they see how much of it is good, how much of it is not necessary, how much of it is not worth
You're talking about a clinical study?
Yeah, clinical studies.
Yeah, actually, we're not doing clinical studies in India because it's quite difficult to do them there. But what we're doing, it's actually a lot of bureaucracy there for that. Okay. But we're doing a lot of basic research.
Okay.
And we are doing cell cultures right now. We have studies ongoing in intestinal cells. And we are asking the question, is there enough NAD in there to do the job? And if there's not, can we fix that? And then we will be looking at the levels in those cells in conditions of health and in fighting diseases and so forth. And we can hopefully answer what the level in the cell should be. Mm-hmm. Now, to figure out how much you should take, you have to do a lot of backtracking. If I take this amount, how much is absorbed, how much gets in the blood, how much goes to the cells, how much enters the cells. There's a lot of pharmacokinetics involved. But at least we are getting a handle, I think for the first time, on exactly how much is needed in the cell to protect it.
What is NNMT and NMT pathway?
Well,
because it's kind of like, I keep hearing that also around NAD.
So there are two pathways that are principal pathways in the cell to make NAD. Mm-hmm. The first pathway, which is not the one you mentioned, uses nicotinic acid, which is a vitamin. And it is actually able to take nicotinic acid and go through multiple steps and get to NAD. Okay. There's a parallel pathway, which is called the salvage pathway. This is the one you're referring to. And under this pathway, it takes nicotinamide, which is the breakdown product of NAD after CD38 has cut it, has chopped it in half, and it takes that nicotinamide and rebuilds from that building block and can make NAD. Now that NAMPT enzyme, which is the first enzyme in that pathway, as I mentioned, it does. That enzyme actually does decline with age. Not a lot, but it does decline. And that could be one of the reasons that NAD falls. We are making less of it because we have less of that enzyme as we age.
You mentioned our mental health also is connected to NAD levels.
Yes,
Can you
for sure.
That's very interesting.
Well, the brain is the most active organ in the body that uses energy. 1/4 of our blood flow goes to the brain. Even though it's a small part of our body, it gets 1/4 of all our blood flow. It's the most hungry organ for oxygen, for food. And the reason for that is that the brain is incredibly packed with neurons and wiring, if you will, to a level that is actually inconceivable to humans. You cannot even imagine. Just in a fly's brain, for example, which has now just been published recently, they took 10% of a fly's brain. Fly's brain is pretty small. Flies are pretty small, pretty uninteresting animals. They don't do a lot of good things, right? They're pretty stupid. So it's a stupid animal, I think stupid. And they took 10% of that.
They don't think they're
stupid. Don't, yeah, you could ask a fly, but if you take just 10% of their brain, it's a tiny speck. They spent 10 years just looking at the wiring in that fly's, in 10% of their brain, 10 years, over 200 scientists. The wiring was 10 miles long.
Yeah.
So the wiring in the human brain is probably well over 10 million miles. Now, all of that wiring needs energy every single second of the day. If you start thinking or start trying to solve a problem or you're involved in some intellectual process, the demand of energy by all this wiring skyrockets. Skyrockets. So the energy consumption in the brain is incredible. Now, all of that depends on NAD. Every single molecule of ATP in the brain came with the help of NAD. So you can imagine what happens if you start to falter. If you have less NAD in the brain, less ATP, there are parts of the brain, many, that will not function at the same level. I'll just give you one example would be language or memory. Let's take language for a minute. Every time you speak, even one word, your brain is firing thousands of signals per second. Every time you say a word, any word, every time you think a thought, all of that uses enormous energy. So if you have insufficient NAD, when it comes time for you to speak eloquently, or to understand something complex, or to solve a problem, or to deal with a complex social situation, you won't have the energy to do it. You might be able to do some of it. You're not comatose, but you will not function at the level that you should be. So if you take like a 95-year-old person with diminished NAD, diminished energy resources, some are okay. Some are not so okay. They may have poor memory. You know people like this. And so as you grow older, as your energy level falls in the brain, it simply can't perform. It's like buying a Porsche and not having enough gas. I mean, you have a wonderful car there, but you don't have the fuel to drive it.
Let me jump in for a very quick second. If you can hear me right now, we know you're watching Soberhead. But are you subscribed? Could you check it for me? Very honestly, our subscriber count gives us real leverage when it comes to convincing the guests we invite to join the show. So, if you want to keep watching some of the best experts in their field right here, please subscribe to the channel.
Let's talk about cancer. Let's not talk about cancer per se, but I know that some cancer researcher friends of mine, when this NAD thing is like I met them actually then because I started using NAD back when I was living in America. It's been a while. They were concerned about if you have a tumor in your system and if it's not detected yet, or if you have cancer and detected, it's not a good thing to elevate the cellular
supply of NAD.
Yeah.
This is an area of legitimate concern.
All right.
Okay. It is true that some cancers, in particular glioblastoma and some other cancers, are using high levels of NAD. They're addicted to it, if you will. And
like sugar.
Yes, you could think of it that way. They need it, so they need it because they're replicating all the time, they're growing, and because they're very wasteful. Cancer cells are not as efficient as healthy cells. They waste a lot of fuel, so they need a lot of fuel to keep going. So you could make the argument, and some people have, that by giving supplements with NAD, you're actually providing that fuel that the cancer cells need. But this would be true of almost any supplement or even food. I mean, glucose is the major consumer. That's what cancer cells live on. Are we going to stop eating? I mean, you can't solve a problem like cancer by selectively removing the foodstuffs or basic vitamins and basic energetic substrates that you need to live. There have been some studies where people have tried to inhibit NAD in cancer in order to kill cancer cells. For example, there's a drug called FK866, which blocks the salvage pathway we just spoke about. Specifically blocks
NNMT salvage pathway.
Exactly. That drug was developed ostensibly even for cancer, I think. And they used it. It caused the cancers to get smaller, but unfortunately, it had a lot of side effects because it also stopped other cells, healthy cells in the body, in particular in the bone marrow. So those patients lost their red cells, they became anemic, they lost their white cells, it became neutropenic, and were susceptible to infection. So losing NAD like that by blocking that salvage pathway was not a great idea. It was essentially a poison, if you think about it. It was poisoning one of the key pathways in the body to produce an essential molecule. Now, chemotherapy is also poison too. I mean, all chemotherapy, but it was a well-intentioned effort. It might have worked, but they were unable to achieve selectivity. They were damaging the host, the person, even more than the cancer. So that never took off.
So basically what you're saying is like if the person don't have cancer or you don't know that you have cancer, it's like almost paying attention to your life as if you're having cancer. If you don't want to use NAD or NMN, you shouldn't eat sugar. You shouldn't do some of the biohacking devices.
That'll kill
many things.
Yeah.
If you have cancer, it's a different story.
That's right. If you have cancer, I would not be recommending to anybody to take any supplements. You're in a very precarious situation. Your metabolism is completely changed. You're on very powerful medicines, many of which are poisons. They have side effects. You have a tumor growing inside of you. Your metabolism is turned upside down. A person who has cancer should be working very closely with their doctor to understand exactly what is best for them. They certainly shouldn't, in my opinion, they should not be taking supplements of any kind.
Let's talk about creatine, because I didn't have anyone who's doing a research on creatine, and also people are so curious about it. So what is creatine? Actually, let me ask this way. Are we able to produce creatine?
Yes, I'm going to tell you an interesting story which will shock you, amaze you. Every person, every day, is using 70 kilos of creatine.
70 kilos.
70 kilos of creatine. That's a lot, right?
Wow. Like, so we have like a 70 kilo of thing excess, or equivalent to 70?
No, they really they consume 70 kilos a day.
So what is 510 gram then?
No, so here's the story. So that's 70 kilos. How can that happen? It happens because of recycling. So we make 70 kilos a day of creatine.
Okay.
And we use 70 kilos a day of creatine.
And where is the waste goes?
Well, some of the creatine, when it's in water, a very small amount, will undergo a chemical transformation to something called creatinine.
Okay.
It's simply a cyclized version of creatine. It doesn't work anymore, and so it's peed out. So we lose about 4, maybe 5 grams a day of creatinine in our urine, and therefore we need...
Is that why we're trying to supplement that 5 gram thing?
Well, we also eat, though.
No, what I'm saying, like we consume 70 kilo and we take 5 grams.
Well, because it's being recycled, but the net loss per day is about 4 or 5 grams. Now, most people are able to get that through their diet.
Like what?
Meat.
What if that person is not a vegetarian? What if they're vegetarian?
There's certain things like nuts and certain things which may have creatine, but if you don't supplement those 5 grams or 4 grams a day, little by little, you will become deficient in creatine.
Oh, so because it's recycling, normally you should have 70 kilo all time.
You do. Every day, every person.
Every day
you lose a little bit in your urine, a little bit,
like
tiny grams.
Okay,
grams, yes.
But then when you calculate 4 or 5 grams a day, in a year it becomes...
You need 4 or 5 grams a day. You have to get it somewhere in your diet. You can't go for days without taking creatine.
Okay.
It's an essential thing in your diet.
So why is that we need to take, or we want to take, maybe not need to take, but we want to take from outside, and how much actually? Because also, like they say, like your body, your muscles use that 5 gram that you take, but it doesn't even reach to the brain, and the brain needs another 5-10 gram.
Yeah, let me answer that. So.
Please.
95%.
I see how excited you are about creatine, because you've been talking about NAD for the last decades.
I've actually going to spend the next 10 years of my life, and this is the truth, focused just on creatine research.
Oh.
This is all I do right now. It's unbelievably interesting and important. And the reason it's important is that we have to understand where creatine is working. Before, people thought about creatine as something for weightlifters. Everybody talked about it with your muscles, and you brought it up yourself, all about muscles. And it's true that 95% of the creatine in your body is in your muscles. The muscles need it. Without creatine in your muscles, they wouldn't function very well at all. But the other 5% is even more important, much more important, because the creatine, that 5% is in every cell, and especially in one place, which is the most important, and that's your brain. Your brain runs completely dependent on creatine, totally, more than anything else. And it is the creatine in your brain which allows the power, the energy, the ATP, to get to all of the millions of places in this wiring. And if you were to be short of creatine in the brain, your brain would start to run down very quickly, okay? And you wouldn't be able to think, you wouldn't be able to process information, you wouldn't be able to understand your social environment or really function at all. So the creatine is an absolutely critical molecule. And if you're low, because in aging there is also a little bit of a fall in creatine, that's a problem. It's a problem because your brain and other tissues, but especially the brain, start to run a little bit low. And I'm in my research right now is focusing very intensively on the levels of creatine as we get older and on how the creatine functions in the body to maintain health for the brain and the intestine in particular. We know that people who don't make their own creatine well are severely mentally retarded.
Oh.
Yeah, they can hardly talk. There are several genetic diseases like that. So creatine is a life-saving, you can think of it like a vitamin. It's absolutely critical to have this molecule in your body to produce it. And there is a diminution, there is a fall off with age. Some people have less. And so the supplements boost that up and ensure that you have adequate levels to support brain function and gut function and other things. Now, creatine's not the last word. In order for creatine to be useful, it has to be processed in each cell. It's not enough just to have it.
Okay.
You have to process it, and it's processed in the parts of the cell which most need urgent energy. So, for example, in the brain, or in other time, I'll give you many examples, the brain, the sperm cells, the ovary, all of these, which are high consumers of ATP, that are high energy consumers, they position the processing of creatine in those places in the cell where it's most needed. In the brain, it's in the wiring. And so the wiring is full of this processing plant, this processing machinery that uses creatine to provide energy exactly where it's needed as you think and, you use your mind.
So hold on, you produce and use 70 kilo.
Yes, but it's recycled
Okay,
constantly.
I understand. Okay, recycled. So you're born with it in a way?
Well,
Where does the supply comes from?
you can make creatine.
Okay, the body under normal condition,
Yes.
if it's a healthy body. And does it stop making creatine if you don't eat certain foods altogether?
There are salvage pathways where and bypass pathways where you will make enough.
All right.
It's not ideal, but you can make creatine.
Okay, still. And again, what's not comprehensible is that while you're recycling 70 kilo again, 70, meaning 17,000 gram
Yes.
of creatine,
Yes.
you recycle,
Yes.
but you need this 5 grams.
Because you're losing it out the urine. And if you don't, if you lose your pool, and if it starts to slip,
So it's like slow use.
yes, over time, yeah.
So young people, maybe they don't need.
I don't know the exact age yet. I'm looking into those questions now. But if you stop getting adequate creatine production, you will become deficient over time. Remember, that 70 kilos is spinning in a cycle. It's recycled. So if you don't have enough to feed that cycle because you're urinating out some every day, then you have less and less and less substrate, and eventually you will get low.
So are you going to look in your research? Because there's a debate on that. I had Matt Kaberlein in my podcast.
Okay.
We chatted like for only a few minutes about the creatine thing. And he's like really, he gets really frustrated with these influencer so-called researchers on YouTube and stuff. And I gave a name and he goes, it's like, she's not a researcher, she's an influencer.
Yeah.
When people start saying like research says you need 10 gram, 15 gram, whatever, is there a base for it? Or it's just like, do you?
No, that's not hardcore science yet. Yeah,
Are you looking into that?
Yes. I mean, we're looking at it at a very fundamental level, cutting edge level, the top, the best research we can do to understand where it's made, how much you need, how it's converted, where it's processed in the cell, what is the nature of the processing, and how can that be influenced by disease. For example, we just learned, actually today, this morning is a good example, we just did research today which showed that during inflammation, the ability to use creatine is impaired. And we found out why. We now know how inflammation can stop creatine from being used properly. So even if you have enough, normal amount, it won't do the job.
This inflammation is so bad.
This inflammation is very bad. And the precise mechanisms, how inflammation hurts you, is what I study. That's what I've been doing now, really since 1987, continuously. And we learned about the mechanisms at that time, and we published a couple hundred papers on this. We really got into the details. What is inflammation? How is it caused? And where does it start from? Our work originally was the first to show that the gut could leak. And we learned how it leaked, why it leaked, what were the stimuli from bacteria that cause it to leak. This was all work I did in the first 20 years of my career. Now it's accepted. At the time, it was considered to be somewhat unusual. But it's become standard of care. People talk about the barrier and gut function, gut leak. And that, as you get older, these microbes in your gut will start to release things into your blood with age. And you get this chronic, growing, ever-growing, progressively growing, and it's called inflammaging. It's an inflammatory process. And it goes all the way around your body to every cell. And so you become progressively more inflamed. Aging is a disease of inflammation where that injury from the inflammation outpaces your repair process. Your repair process may be fine till you're 30 or whatever, 35.
So basically, inflammation is the CD38. The inflammation doesn't allow creatine to get processed.
The gut feeds the inflammatory process, which builds, that stimulates CD38. CD38 goes up because you're inflamed.
I understand.
And the reason you're inflamed, in my opinion, is because you have the entry of microbes and microbial products, especially, through the gut into the blood, and that increases over time. So we're studying that at the fundamental level. I have cells in culture right now as we're speaking, where gut cells, where we're learning what are the mechanisms by which these microbial products can get in.
So basically what you're saying is that with age, at some point, you're going to have a leaky gut.
Oh, yes. Yeah,
I mean,
progressive.
even though
it's
if
not,
you do everything wonderful.
Yes. Yeah.
That's a huge statement.
Well, I mean, we have to accept the fact that people have mortality. I mean, people don't live to 300, 500.
Just before you, I had a podcast with a longevity investor, a Russian guy. So we were talking what they can do. So I think that the next thing is going to be them bioengineering all the organs and replacing them. So,
well, that's one way. I would prefer to see better understanding of the science of how this inflammation. Yeah, so you can thwart it. You can stop that. I mean, we were able to show that cytokines and inflammation cause the gut to leak. Published that in 1995. Now we can block those cytokines and stop the gut from leaking, at least in animals and in the cells. So it's this kind of research. There's certain things in your diet that will dampen the inflammation in your intestine. And so you can do things outside of medicine, but eventually medicine has to catch up with this, and we have to find a way to stop the inflammation.
Well, we come to an end, but I think that at some point I need to do a secondary podcast with you because you have so much information that 1 hour won't be enough. Andrew, thank you so much for coming me all the way from Israel and joining my podcast. It was such a pleasure. I think we could speak forever.
Okay, it's a deal. Thank you.
Next time.
All right.